Okay, hello everyone. Welcome to another design review, heading for version 13.1 of Wolfram Language. I noticed the note here that this is the 599th episode of my live CEOing series here. My gosh, it's hard work. Okay, we are looking at some calculus and algebra functionality. We hope
I think we've covered all that. You were just taking a first peek at structured arrays.
Yes.
That's
okay,
what
and this
I
is
think
a lot
this
of
was.
documentation stuff here.
Yeah.
By the way, I think I've sent some mail about this. I mean, there's a lot of stuff with graphics where we are under-documented, and a different topic. Do you agree
Yes.
with that statement, or are you do you want to disagree with that statement?
What specifically are you? I mean, I'm not sure exactly what you're thinking of.
Oh, I don't know. All kinds of things to do with labeling and this and that and the other. I mean, I keep on seeing under-documentation.
Yeah. I mean, there is no real labeling for graphics.
Well, I
For
know,
visualization there is, but
yeah, I understand.
But
I mean,
so generally speaking, as a sort of an overview, I think every reference page needs to be rewritten to some extent.
yeah, but there's 7,000 of them, so that's going to take a while.
Yeah.
I think that well, that's fine, but I think we need to. These graphics ones are and visualization, whatever you call it.
Yeah, the visualization ones we are doing that's happening all the time. That's
okay.
definitely
Well,
happening.
there needs to be more work. We should go through it. Separate meeting.
Sure.
Not for this meeting.
That's for sure happening. Graphics.
We need that. We need that to happen. Okay. So we need that separate meeting, probably.
Yeah.
Okay. List plot, all those things it's got.
Well, that's visualization, right?
Okay. All right. So the story here is is this under the hood some kind of structured array object, or is this?
Yeah. So this is a structured array, and the point of structured matrices and structured arrays is that they have short specifications and efficient computations for a subset of the computations. Now, we've done this framework-wise very much how we built sparse arrays. And in the sense that if there is no special operation for this class of matrices or class of arrays, then it will convert it to a normal array and it will perform the operation. So it should never fail, really.
Is it really?
On the other hand,
zero?
You can
really right that that's zero? No, that's just bullshit. It's wrong.
Oh, part.
Yeah, it's just wrong.
Yeah, it probably shouldn't do part.
Really?
Yeah, part shouldn't work.
It works for sparse arrays.
Yeah, but we're going to have to look at that specially then. I think sparse array is no entry. Or maybe it isn't.
Well, it was zero because I didn't put an entry there. See, it'll work fine.
Yeah.
That's the expectation people are going to have, is that that's going to work.
Yeah. Yeah. Yeah, we need to look at that. We've got to make that work. But there could be happen, like with sparse arrays, something that you can represent as a structured array. So for instance, often like a permutation matrix, it only takes a vector to specify, and
I understand the point. Yeah, right. I mean, okay, so these operations, so another question is, in the blob, is that a picture of this actual permutation matrix or not?
In this case, it is, I think. Or maybe that's a generic. I mean, so.
No, it looks like it is.
Yeah. Well, I wonder if that's done generally. I don't know how far that stretches. If you make that 10,000 long, it can't be that. Range 10,000.
Well, let's just do range of 100.
Okay. Oh, well, that's not going to work. It needs to be cut off somewhere.
Maybe it doesn't. Maybe it's doing something reasonable here. Really? Is that right? That doesn't seem like it could possibly be right.
No.
Okay, so something is goofy there. And anyway, it went from purple to gray mysteriously. Who's responsible for this? Can somebody speak up, please?
Yes, Jan is looking after that, so I'll ask him to fix it. I mean, he's working with Rob as well, but Jan Magdalene is the main person. I'll ask him to fix it.
Okay. But you understand, I mean, so what do we want to have happen here? Did this go through graphic design? First question. Did this go through graphic design?
No, okay. Nothing goes through graphic design. We use Tim.
Okay, but you've got to do that. That's part of our process.
No, we don't really use graphic design.
You've got to do that.
Only when you insist on it.
Okay, well, I'm insisting.
Fine.
Okay, fine. Yeah, okay, fine.
But they're usually not educated in visualization and stuff.
Well, I'm sure it'll be fine.
Okay.
But this is not going to work, right? Whoever did this.
No, I just told you it's not right.
Yeah. So, I mean, and personally, I think that this, the purple theme of this is not very convincing.
I agree with you.
And I don't know how it relates to sparse array and so on. I mean, we could try and do that review here if we can find somebody from design. But we'll get to that in a minute. Maybe somebody can try and track Jeremy or somebody else down. Okay, second point. In here, is there nothing else that is meaningful to say about this permutation matrix?
No, probably not.
Okay, fine. If that's the case, so be it.
For the other ones, there will be, but this one is just can't really.
Okay, so oh, come on.
What is that?
Yeah, you want it to be a permutation matrix, right? So that's not a permutation matrix.
No, I understand, but why is the message text not found?
That's a part of the prototype build process where they can't get it in.
Okay, all right. So what are you telling me about this? This isn't a permutation matrix?
No. Because it must have exactly one and all zeros in each row. Or
column. That's right.
That's all. I mean, that's, of course, yeah. This is
okay. By the way, I'm not certain, given this, okay. Maybe this does work.
Actually, I didn't say earlier on, but the part is correct because it's just a list.
I know.
Yeah, so I mean, so I think it's all good over there, really.
Yep.
What did you do before?
I was confused because it said 0, but it probably was 0 because most of the permutation matrix is 0.
Oh yeah.
Okay. I just got confused.
Yeah.
Okay. I hate it saying complexity order n. I would say time order n.
Yeah.
Okay, fine.
Okay. All right. What should I look at here? So I mean,
this is the beginning. So to give you the big picture, this is the beginning of this is like special matrices, like we have special functions. So we'll add some more. We'll eventually open it up so users can add new ones like this, new families.
Yeah. Why doesn't this work? Shouldn't this work?
Signatures.
No, signature is not defined for matrices. I think signature is a thing for a permutation, right?
No, I understand that, but doesn't this?
No, I think look up signature.
Well, no, I understand. I'm saying this defines a permutation.
Oh,
right?
I see. You want the actual property of that matrix.
That's what I'm thinking. Yes. I mean, why wouldn't we have that?
Yeah. So there are.
So you want the determinant for it. That's what you want. The determinant of the matrix, right?
No, could we make this matrix represents a permutation?
Yeah.
Right?
So we could.
So the question is, what is it the determinant of the matrix? Yes.
Yes, it's the same as the determinant.
Okay. So I mean, for example, converting this to a permutation, how would I do that?
There's a property at the bottom you can get.
But also that works.
Apparently.
Yes.
Okay.
Didn't know that. Someone must have done that specially.
Well,
Yeah,
yeah.
Because it would not, there's
Right.
no way the permutation list could know about that on its own.
Yeah, I understand. Autocomplete not working here.
Not double brackets, just single brackets. Now, I don't think autocomplete works until we built, right?
Maybe not.
I think.
Okay, nice. So, I'm sorry, for a permutation matrix, if I just give it okay, that worked. For an upper triangular matrix, can I give it the ragged matrix? I should be able to.
It didn't seem worth it. I don't think that will, because it's still harder to specify that. We could do it, but it's like, it's not so useful.
You should do it.
Okay,
there are plenty of cases where I've had things where I compute stuff.
Sure.
Exactly this. I mean, I compute stuff by having a table. I'll make it up for you. I mean, table
Right.
I squared plus j. I goes up to 5. J goes up to I.
Right. Yeah.
Okay,
so if it looks like 1, then it must be 1 kind of thing. Yeah. Yes.
Right. I would make that an upper triangular matrix.
Fine. Sure.
Right there. Now,
Sure.
What's the relationship between all the stuff about diagonal and so on, and band matrix and all that kind of stuff to this, and band to this?
So that will come back. So some of the things that we've introduced a little bit too early, like Vandermonde matrix, and we had to introduce them, but an identity matrix, diagonal matrix, there are structured matrices that can be done very efficiently. These ones are not. They will just generate a matrix.
Right.
Which
is not a bad thing. The identity matrix is a fine thing to generate and very useful, and don't mess with it.
Right.
No,
but we need a second argument that allows us to get it out in different forms.
Yeah, no doubt. As a many different kinds of things.
Mm-hmm.
I mean,
yes.
Permutation matrix or this or that or the other. There are many different structured matrices. But presumably, if I take this and I say permutation matrix of this, I will get the right thing.
Identity permutation. Yes.
Right. But I mean, what your point is, I'm just trying to understand the pattern here.
So the pattern is that this is something that kept coming up, right? So for us and for our users, when you're trying to push certain functionalities, so Vandermonde comes up when you solve interpolation problems.
I understand the reason for these matrices. I'm asking a different question, which is that in the pattern of identity matrix, which is ordinarily an ordinary expression, but what you want is a case where you can generate the special representation without having to generate the non-special representation and then specialize it. So
exactly.
Mm-hmm. Right.
Okay.
So
I'm asking what the pattern for how we represent that is.
I think a candidate pattern is that there is a second argument. I think identity matrix actually already has that, can generate a sparse array. But
yeah, it does. Look, I would argue. I would argue that there may be value in having an option, perhaps in addition to a second argument, but a general option. I don't know, target structure or something like that. I don't know if that's right.
Well, it would be kind of nicer, but normally we've avoided that because it sort of changes the form in some way.
Yes, except that the argument here is it doesn't in fact change the semantics because these things are just.
You're right.
Not
so I would be in favor of that. It's cleaner. So as far as I'm concerned, it's a cleaner solution.
Yes, I agree.
So if you're okay with it, Stephen, I think that's a great idea.
I'm probably okay. Target structure, maybe arrow, and then the name. But now, I mean, what was I going to say? The question, I lost what I was going to say. Okay. Right. All right. Let's keep going here. So then, okay. Now, I mean, I assume that the operations you are describing here have the feature, I mean, a determinant just gives an integer back. An inverse presumably gives, well, I don't even know. An inverse of a upper triangular matrix doesn't give an upper triangular matrix. So it gives some.
No, it gives an upper triangular matrix. It's closure. It's a closed under that.
Okay, all right. But
it doesn't in general. In general, you can't, you know, these structured matrices, they've come up for different sort of purposes, and they don't have closure under everything. So it then will have to get you know, to a normal matrix.
Right. So there's a good reason to have this target structure option, because it could be that there's a case where you want to try and make it, if you can make it sparse, you want to make it sparse and so on.
Right.
Okay, I've got another question here, and then we have Jeremy here and we can talk about some graphic design.
Mm-hmm.
My question is about data structure. I think we just briefly touched on that before.
You mentioned something.
Right. Should these matrices be data structures? I think yes.
So they're all structured arrays with a list of operations, basically. So we built a system that works for these, that, you know, when you come to an operation, it will check whether there is a specialized operation, and if not, it will make it a normal matrix. And
no, I understand that, but I'm saying when you're dealing with a compiler, for example,
yes,
you're dealing with, you know, we definitely, you know, sparse arrays are definitely a thing that the compiler can understand.
Mm-hmm.
Surely we want upper triangular matrices to be another thing that the compiler can understand. And for that to be the case.
I see. We can work with, I mean, so Rob and Jose has been key parts of sort of building the framework. We are now filling it in basically with concrete structure arrays, but they're also the right, you know, Rob in particular in the compiler team would be the right to sort of figure that out, whether we can get that
right
more deeply.
I suspect that, yeah, right. I think it's going to be
compiler.
important, because I think data structure.
We'll pursue that. I don't know if it's data structure, but compiler integration, I understand completely.
Yeah. Okay. I think it's going to be useful to have it as a data structure, because I think it's going to be, you know, at the very least, even if it's identical in functionality to what is provided in the top level expression, mm-hmm. you know, when people look through the list of data structures and it's like, can I use these things as data structures? That will be a place, you know, that will be a useful thing.
We'll look into that for the next cycle.
Sure.
Okay.
That will be a framework extension.
Definitely.
Okay. For Jeremy, we are looking at these blobs, and I don't know. I mean, is there a blob gallery somewhere?
No, we didn't prepare for that. We can do that, but we don't have it.
I mean, okay, but I mean, we're using this purple. You're using this purple motif everywhere, except that you don't have a purple motif there. It's red for some reason.
Honestly, I haven't really seriously looked at that. You know, we wanted to get, there were more other challenges to get over. So.
Well, so maybe we can do this offline with Jeremy. I mean, I think my only point is, you know, purple is a color. I don't know what it's got to mean something. I don't understand what this palette is. I don't know how it relates to other things. I don't know why those symbolic things are red.
I agree with you. But I'm just saying I haven't really thought about it, because there were more serious things that was initially to get over.
Okay, but do we think we have a pattern for, you know, in these summary blobs, for what the color palette is for different kinds of things?
No, I want to go over it first.
Okay, all right, fine. Well, then this is a null discussion. Okay.
I'm sorry.
So I think, Jeremy, you're
That's fine. I can follow up, Roger, if you want to pull me in.
Yeah, that would be great, Jeremy.
Kind of Tim will be involved too.
So what we'll put together is what the I couldn't even tell you what the design is right now. So there's a bunch of questions I have, and then we'll put together a gallery of what it is, and then let's come up.
Yeah, it should be fairly straightforward. Okay.
Yes.
All right. Okay. Thanks, Jeremy. Okay. All right. So I think I understand these matrices. They're okay. Block diagonal matrix. So that is something very related to the band discussion, isn't it?
No.
Yes.
No.
Look, we have this mechanism for block diagonal matrices, if I'm not mistaken. Band.
A banded matrix is a thing, but
no, I know, but there's a way of doing block diagonal. Okay, what does lower triangularize do on? Okay, so here's another question: LU decomposition. Does that give? What does that do with respect? That will be a good place where target structure would make sense.
Yes. And so the idea is to be able to shift, so all these matrix decomposition algorithms, they produce basically structured matrices that are then easy to work with. And now they can return these things that are both easy and efficient to work with.
Right. But so lower triangularize can have a target structure option that can say lower triangular matrix.
Good idea. Yes.
Yes, definitely.
Okay. All right. I'm trying to understand. There's somewhere. What the heck is this? Why is this stuff?
What was that?
That was the thing where I hit the
TV.
Somehow,
it was like a TV.
Look. It was a thing. This is a bug, and so if somebody could mark the time code here and try and figure out what I did, because that's happened to me multiple times, and I think it's something to do with the way focus is working on this input field here.
I've got that.
Okay, I don't know how it did that. Okay.
That's another one. We don't have it yet, but
we'd like to go back a structured array if it's requested, basically.
Yeah, but we don't have it yet. But
yes.
But this is going to be a mess, right? Because here, this is called diagonal matrix, and you can't return a thing called diagonal matrix.
Why not?
Because we
have many things that are both constructors and representers.
I guess. Well, and this is a good reason to have an option because we've got all kinds of arguments hanging out here.
Yeah.
I think it's also interesting. This target structure thing might also be interesting to return data structures in some cases, not for this family of things, but in other cases.
Yeah.
Just a more general option. Yes.
Okay. So what were we looking at? I was still trying to remember how we done block diagonal matrices before. We've had a mechanism for doing them. What is it?
The best I know is, Roger would know better, but there is a WFR function, but that's about all I know about. We have had a very tough time.
I've had to write this function myself every time I use it.
So we need it for things like, the decomposition that we did for like the core nilpotent and other things that we did for the early release. So we need this ourselves, the block diagonal matrix.
Okay, well, let me look at it here. Okay. Well, I wouldn't have given that example, but whatever. I mean, doesn't seem like the right example to give. It seems like the example you want to give is something which has a matrix of different sizes.
We can change that, yeah.
And I'm not suggesting this particular one for now, but oh gosh. And if I say normal of this.
Yes, then it should just give you the right. And you can say matrix form to get the matrix form, etc.
This is a mess because, you know what? This is a mess. diagonal matrix, identity matrix, they just give you back the matrix. This is incredibly hostile to people. People are going to get really confused. They're going to say, identity matrix gives me a matrix, but permutation matrix just returns some weird permutation matrix thing. How do we deal with that? So like in the case of this, block diagonal matrix, some of the time I'm just going to want to get the normal version of that. And we've got a confusion of names of some things returning the normal versions and some things not. So how do we deal with that?
Well, I mean, I guess if we do the target structure option, we could get, even these constructors could have that.
Yes. No, they absolutely could. The question is what the default is for small ones.
I really think that the default should be to return the structured thing. Otherwise, we're stuck with the inefficient.
No, but that's not true for a 3x3 thing. It might be true for a 1,000 by 1,000 thing. I mean, for many purposes, for small ones, people are not going to want the structured thing.
Yeah, so if we make it automatic, and then it sometimes does it and sometimes doesn't.
I'm not sure. I mean, if we've managed to get the plumbing correct, that would be okay.
Well, I mean, first of all, I was going to suggest we introduce this as experimental for now until we have a little bit more and a little bit more of the pattern sort of, fleshed out. I think it's prudent.
Let me think about this for a second. I mean, let me just think about it for a second. There are really two ways to think about this. I mean, one is the way that we do packed arrays, for example, where the thing walks and talks like the ordinary expression. It just happens that internally it's stored some more efficient way.
But it fails mysteriously for people.
Only in terms of speed.
And storage.
Yeah, it doesn't, I understand. But that's a different issue. That's a different problem than the problem of it being, this is where we make a mistake so many times.
No.
It's like we got elementary. No.
I mean, if we just want to be a toy system, we can.
Yeah, but we don't. We want to actually be it so that people can understand, and they don't want to pick up their computer and throw it across the room because it did something that they don't understand.
Yeah, I agree.
Okay, so let's. What I think, the best way to do this would be that it basically is invisible. That this is something which internally you say permutation matrix just makes a matrix, just looks like a matrix, but internally it's a much more efficient representation where its display form is that permutation matrix blob whenever it gets big, which is much more useful than a tiny piece of some giant 1,000 by 1,000 matrix. But
we need Rob here in this discussion if this is going to go anywhere, because I think that this is going to be blocked on that it's not doable. I mean, I know you like that, but just.
Yeah, well, make it experimental. It's not, I mean, I think I think we should consider making this target structure error automatic thing for now, where the real solution is this, invisible data structure solution. I mean, this is an imitation of that, which will be plug compatible, assuming that all the plumbing is done correctly.
We need, no, I'm not committing to it without Rob in this discussion, because it may or may not be doable. It may be sort of prohibitive.
But you understand what I'm suggesting. What I'm saying is, if the plumbing is correct, it doesn't matter whether you have the blob or whether you have the literal expression there. You'll always get the same results for every operation.
Right.
Okay, so if that's not true, then, like for example, length. What does length do here? Well, let me make a. Lovely. Weird. Well, I don't know if that's weird. Is that right? I'm not even sure. It is. Okay. Well, we may already have this solved. And it's really just a question of what, it's almost just a question of print forms.
Mm-hmm.
Right.
I mean, maybe this is completely solved already. And I mean, what happens if I do map on this? It's fine.
Yeah, I'm sure Jose has gone through a long list of things like map and all that. He's got a checklist which he goes through every time for these things.
Well, this may be just a question of print forms.
I kind of agree, because even to me, it looked like for a small matrix, if it's possible, then to show the actual matrix would be much nicer. This is a bit frustrating to do a matrix form of that.
Right. The only thing that might not work is if you select an element interactively, given that you see the matrix.
Right.
But I think that's a minor issue, honestly.
Yes. Yes.
Okay. Yeah, because I think people are just going to want to say, okay, I personally think it would be nicer to make the normal expression for small cases, but I'm not certain about that. That's a question for Rob.
We'll follow up, okay, Stephen.
Okay.
I understand where you're standing, and that's actually where I was trying to get it to several, rounds ago. But...
Fine. Okay. All right. Any more on the matrices?
Not really. I think that, as I said, we will evolve this and fill this in and then open it up so that people can create their own as well.
I mean, just so I understand, I mean, there's also structured tensors too.
Yes, this is called structured arrays. There's a guide page for it.
Okay. All right, fine. So we're expecting structured, block diagonal tensor and things like that too.
Yeah, we even have a structured vector right now called like unit vector.
Right. Okay, well, look, if we do this thing with this elision, then, it almost becomes the case that we could change the return value of block diagonal of what am I thinking of
diagonal matrix.
Yeah, diagonal matrix, right.
Yeah.
And nobody would know the difference.
Right.
Okay. All right. What else do we have to go over? What's this model predictive control design?
No, this was this was when we had more optimization. So we already had that design review, but that was an application for optimization, but that shouldn't have been left there now that we had cut out other things. Fine. So sorry about that. But
standard interval. Okay. Interval support. So, I mean, this is what we introduced in 13.0, right? The centered.
Yes. Concept. Adam is here. Yes. So yes.
Okay. Well, this is a lot of work and very important, but not probably what we should. I mean, this is really important stuff. I don't know whether let me.
It's happened.
Yeah. Well, let's pick a random one and look at it.
Mostly Itai's work is very nice work. He's just gone through the whole page and rewritten everything. And where they were before that is also worth commenting. There are like 5 examples.
Do we really want a thing like this?
Under applications only.
Yes, we allow that.
It should be under applications only. That's the only place we allow it.
Yeah, it is. Okay, fair enough.
I mean, there's a lot of work over here. It's a major project finished.
Well, it's super useful.
It is.
Wow. Okay. I mean, we should think about how we can leverage this as we get more and more of these more educational, more complete pieces.
Yeah, we need for the linear algebra MOOC, we thought the documentation was not adequate at that point. So this kind of will help people who go to the course and then look at a documentation to learn it from you as well in more depth. That is the whole idea, actually.
Fine. Sounds good. All right. Anything else we need to review here?
I think we covered everything. Could you just scroll to the bottom? But I think you covered everything.
Well, let's take a look here. This is
Yeah, we released the differential equations class.
great.
Algebra should be done in next 3 months. Multiple calculus, January 2023. And probability we're just starting off, we'll probably have it sometime next year.
Book forms, those courses will be nice too.
We're exploring that as we speak.
Yes.
We're working with the Wolfram Media folks.
Okay. And that they'll act as course books. I mean, would they be books in a similar format to like EIWL and Etienne's book, or
may not be as nice, frankly.
What's that? Say it again.
They may not be as nice because, I mean, I think that what we'll do initially is to have them mirror the course with, like transcript based things, so people can actually use them as the notebooks, and then we slowly take it to the next one. So Roger was saying something. Yeah,
we have a longer game plan where we want to build. This is also for another time. I want to discuss that with you, Stephen, where we build books that you can buy, or you can get them for free distributed if you have Mathematica, and we have a bookshelf in the product where you add in your books.
Yeah, fair enough. Well, I mean, that relates also to the courseware repository.
Yes.
Also being worked on. Have you been connected to those guys? Do you know what
wait, I mean, I vaguely heard about it, but I don't know what's happened there.
Well, what they've been mostly doing is building the question framework, right? Building the assessment framework and the question framework, which is now in pretty advanced state.
Okay.
Okay. And presumably these courses use that or will use that.
I thought we already did use that.
Maybe you use a more primitive version of it.
Probably.
I think it's been
probably an earlier version.
Yeah. It's been productized. I mean, it's probably the things that we used for EIWL were an early version.
Mm-hmm. Yeah, so I think that's what we've been using for calculus and linear algebra, etc.
Right, so that's been productized, and then the next step for that team is the courseware repository.
Okay. Then I probably haven't seen that. Who is
Brady? I think is a relevant.
Brady.
person.
Okay, fine. Good.
And yeah, I think it's highly relevant. Mm-hmm. And have you been using those recording tools that were originally made for me for doing recording of course material, with all those the thing that has that whole thing that you run on an iPad that talks about next example and so on?
I think some people like it. The elementary algebra people like that pattern. And so I think the more modern courses after the first couple are using them. And they have because most of it takes place at home nowadays with people not able to come on site, even so far. But yes, that's being used quite nicely. And the kind of stuff that Dave Witoff uses, is that what you're referring to?
I don't know whether Dave has used it. I don't know.
But I think we use it quite a lot for the elementary algebra because it makes sense over there.
So there's usually two stages to writing these courses. One is to sort of come up with a syllabus and write it out. Then there's a second stage where there's more editing and recording going on.
Right.
Yeah.
So that's either Wolfram U team or someone else, who takes on that burden.
Have you guys seen Etienne's book, by the way, the printed version?
Yes, I'm sure Roger has.
All right. Anything else here?
No.
No. Okay.
Oh shoot! I am in such trouble. Bye.
See you. Bye-bye.
Thanks.